Hello, this is Ms. McLean, and this is the hand computation of using the binomial distribution probability formula. So we are going to look at this problem. It does have three parts. You can't see part C right now, but we are going to do all three parts. So let's read our problem. It says, according to the U.S. Red Cross, only 7%. So I'm going to circle that, because that's important. That is my P in my formula. That's my probability. So 7% of residents have type O negative blood. Assume that a blood bank has recruited 20 donors. So that total is my N. And we want to round 4 decimal places. So this is really important because we are actually going to round as we go. So we're going to round each value, and then we're going to tally it all up and then round again if we need to. Okay. So the acceptance of the answers are going to be a little flexible since we're going to be rounding as we're going. Okay. All right, let's look at part A. It says, what is the probability that 2 or more have type O negative blood? So the 2 or more is going to represent our X. So you can see in our formula, we need an N, we need an X, and a P. So now that we have an X, now we can plug into our formula. Now we do need to talk about this 2 or more a little bit. The or more means that I am starting at 2 and I am working my way all the way up until our total N, which is 20. So that means X is 2, X is 3, X is 4, and so forth, all the way up to 20. That is a lot of calculations, okay? And we're doing this by hand because this probability is not in my table, okay? So I don't want to make all these calculations if I don't have to. So I'm going to suggest in this case, we use the complement. So the complement would be the opposite N, which is 0 and 1. So that's the values that's not listed here out of the 20. We don't have 0 and 1. So I'm going to jot down, and this is the complement, which means we're going to have to take this total and subtract it from 1. Right, so this is kind of what's going to happen. So I'm going to figure out P of 0, P of 1, I'm going to add the 2, and then we're going to subtract it from 1. Once I do that, when we subtract, it's going to leave me with the results of 2 through 20. Okay, so this is the best route to take. So I'm going to go ahead and jot down my formula. I do recommend that you write down the formula at least once with all of your values plugged in. Let's see, X is 0 for our first one. P is, we want to change that percent to a decimal. And let's see, our exponent is X, which is 0, times 1 minus our P, and N minus X. So N is 20 minus X is 0. Now, I don't recommend you type 20 minus 0 in your calculator, because if you do that, if you type all of this and then to the 20 minus 0, it's actually going to calculate this incorrectly. So we have to be careful. And I'm going to type in 20 in its spot. Okay. I am going to go ahead and write down P of 1. Of course, this is just scratch work. Like I say, you don't have to write down the formula every time. I recommend you do it at least once. And then we want 20 minus 1, which is 19. So that's what I'm going to put in my calculator. Okay, so now that I have it written, let's go ahead and start the calculations. Okay, so we're going to begin with 20. Probability, go to your combination, 0 times 0.07 raised to the 0 power times 1 minus 0.07 raised to the 20th. When we hit equals, here's our decimal. Again, we want 4 places, so 0.2342. So I'm going to go ahead and jot this down. All right, so now we're ready for our second go round. And the trick with this calculator is if you hit up, it lets you type over what you already have. So I am going to go ahead and override my zeros with 1. Now be careful, we don't want to override this 0. That's part of your P. right? So it might be a good idea to jot it down if you want to clearly see where the substitution is going to happen for you new X, right? And then 20, we're going to override to 19. So that's the quick way. So really you only have to type this in once. So I'm going to round 4 decimal places. This is 0.3526. All right, so I'm going to go back to my problem. So we talked about this already. We want the complement. So that means I want 1 minus this total. So let's go ahead and get that total. So 0.2342 plus 0.3526 gives us 0.5868. So that is what we're going to subtract from 1. Clear this out. And we get 0.4132. So that is the probability that 2 or more would have type O negative blood. So out of these 20, 2 or more, this is the chances of having type O negative, okay? Now let's look at part B. Part B says, what is the probability that fewer than 5? So again, that is going to be our X, have type O negative. Fewer than 5 are the values 0, 1, 2, 3, 4. So its complement would be 5 through 20. So notice this is a lot of calculations. I don't want to do the complement this time because that's too many. Now the good news about this is we've already calculated P of 0 and P of 1. I'm just going to take that from part A, right? So that's part A. And so that means we need to calculate 2, 3, and 4. So I'm going to go ahead and jot that down, 2, 3, and 4. I'm not going to rewrite the formula. I'm just going to simply go to this formula, and everywhere I see my 1s, I'm going to substitute for 2. So I'm just going to kind of circle these real quick, just to remind me that this is where my substitutions need to happen. And I'm going to jot down 20 minus our number for X. Okay, so I'm going to do that basic math before putting it in my calculator. All right, so let's go ahead and give this a go. All right, so again, we're going to begin with X to be 2. I recommend that you pause your video, go ahead and give this a try on your own, and then you can see if our answers match up. Right, and 20 minus 2 is 18. Right, so remember we were around 4 decimal places, so this gives us 0.2521. I'm going to hit up and I'm going to exchange my 2's for 3's. And 20 minus 3 is 17. Right, so this one we're rounding up. The 6 tells me to move the 8 up to 9. And let's go one more time. And 20 minus 4 gives us 60. All right. So now that we have our values, we want to join this up with 0.5868. I'm going to go ahead and calculate this up. All right, and so this equals out to 0.9892. So I want to remind you that we are finding probabilities. So if I hit equals and I get a value that's over 1, I know I made a calculator error, okay? A lot of times when I make calculator errors, it's because I don't put in the 0 before 7, that 0.0. So just be careful when you're typing in that formula, because I know it's a lot that's going on. So I usually tell students, slow down for this problem. Make sure your calculations are correct, okay? So this is the probability that fewer than 5 people would have type O negative blood. All right, let's look at our last part. Part C says, would it be unusual? So I want to remind you, unusual, that's for probabilities that are less than 0.05. If none, and none, that means 0. So that's our X in this case, none, which would be 0. So would it be unusual if none of the donors have type O negative? Well, we already calculated P of 0 up top here. So notice we are reusing a lot of information we've already done. And we got the probability of 0.2342. So of course we want to answer the question, is that less than 0.05? And making that comparison, we know right away that this is not less than. Therefore, it is not unusual for none of the donors to have type O negative, okay? So that's basically how you do this hand computation. I know it is kind of tedious and long in the beginning, but once you get that formula in once, you can quickly make your calculations for other probabilities. I also recommend you kind of do a little bit scratch work like I've shown here to see which one's better, the X itself or its complement, because you can see part A we used the complement, but part B we did not use the complement. To figure out which one would have fewer calculations, okay? So hopefully you're finding this video helpful. If you've got any questions, feel free to email me.